All right, so here's our example problem. Again, it's a composite shape. Two rectangles, we'll call it the big rectangle, 4 inches high, 3 inches wide. And the small rectangle, 3 inches wide, 1 inch high. So I've already broken it up for you. What I generally do is, I mean, we know rectangles where the centroid of a single rectangle is. I mean, it's right in the middle of that rectangle. But now we've got a composite shape, a shape that's made up of more than one thing. So what we do is we break it down. We know where our origin is, and if it's not given, we locate it where we want it, but here it's given. So we start, just one shape at a time. Big rectangle. What's the area? The area is 4 inches by 3 inches. That's 12 square inches. From the origin, how far in the x direction do I have to move to get to the big rectangle centroid? And you'd say I have to move 1.5 inches. Okay? Area times x gives me ax. So 12 times 1.5 gives me 18. From my origin, how far do I have to go to get to, in the y direction, do I have to go to get to the centroid of the big rectangle? 2. 12 square inches times 2 inches gives me 24. Okay? Did you understand that? That's all you got to do with centroid. Now we do the small rectangle. It's 3 inches wide, 1 inch high, it's 3 square inches. What's the x distance? The x, all of our distances, once we set the origin, that origin is always referenced back to. So it's 4.5, because we always come from the origin that we've established. So you might say, oh no, that's half of 3, that's 1.5. Well, that's if you had one little rectangle, but we don't have that. So we're trying to get to that point. So it's 4.5. So 3 times 4.5, that gives me 13.5 for a times x. What about the y? How far up in the y direction do I have to go? 0.5, 1/2, 0.5. So 3 times 0.5, 1.5. I'm then going to sum up my area column. That gives me 15 square inches. I'm going to sum up my AX column. It gives me 31.5. I mean, actually, the units would be inches cubed, but you don't care too much about that. And then the AY column, you're going to sum that up. And again, you get 25.5. All right? What's our formula? For x bar, our formula is sum of the AXs divided by the sum of my area. And that's going to give me what? 2.1. The y bar is going to be AY, 25.5, divided by sum of the areas, that's 15. What do you come up with there? 1.7. There you go, folks. That's the centroid. From my origin, I have to move x 2.1 to get to the y centroidal axis. And from my origin, I have to move y 1.7 to get to the x-axis. The intersection of those two axes is the centroid.